Hello. You're about to watch one of the webinars which we gave during OHBM 2020 on automating your BIDS workflow. We re-recorded this presentation due to technical difficulties, but you'll find the questions from the live webinar following the recorded presentation. Our speaker today is Dr. Maggie Mahan, who is a scientific solutions engineer with Flywheel. Dr. Mahan earned her PhD in biomedical informatics and computational biology from the University of Minnesota. The focus of Dr. Mahan's work has been at the intersection between computation and neuroscience. She spent time during her academic career working toward the discovery of neuroimaging biomarkers, as well as the development of novel methods to enhance diagnostics and prognosis. You may also find the other presentations that we gave during OHBM on our website, including Open Science with Flywheel and using Flywheel for data curation and machine learning. Now I will turn it over to Maggie.
Thank you for coming today. My name is Maggie, and today we will cover the tools and resources available from Flywheel for automating the BIDS standard with your neuroimaging workflow. Before we get started with the BIDS standard, let me introduce you to Flywheel. We are an informatics platform for biomedical research focused on maximizing the value of your multimodal data by reducing IT barriers and optimizing your research workflow, from capturing and curating your data to computation and collaboration. We support both imaging and non-imaging data and provide a foundation for deploying data processing pipelines. This includes several features that support machine learning applications. Overall, the Flywheel platform offers you a centralized infrastructure for scalable and collaborative science. At Flywheel, we are committed to open science. We have open source tools that provide transparency and flexibility when working with your data and when sharing it with collaborators. This includes an open API and SDKs for several popular programming languages. This makes working with your data in Flywheel both transparent and flexible. As part of our commitment to open science, we believe that BIDS is an essential standard, both for sharing and reuse. Therefore, we support this very important standard throughout our platform. We have a variety of tools that you can use to streamline the integration of BIDS with your existing workflow. Importantly, we have tools for curating data sets to the BIDS standard and for viewing the BIDS directory structure of your curated data set in the Flywheel UI. We also support several BIDS apps as Flywheel Gears and have the tooling to import and export BIDS curated data sets. I will be discussing each of these tools in more detail throughout the remainder of this talk. First up, I will briefly go over the BIDS standard. BIDS stands for the Brain Imaging Data Structure. The purpose of BIDS is to standardize how we describe and organize the data files from neuroimaging studies. To illustrate this, a set of DICOMs in a directory is shown on the left side of the slide. These DICOMs are then transformed, ultimately turning into what the directory structure on the right side of the slide, and that is the BIDS standard. Now, achieving this standard doesn't come without its challenges. For example, a typical transformation would take about 5 stages to get a data set from the DICOMs to the BIDS standard. The first step is to convert the DICOMs to NIFTIs and extract any associated recordings, such as physiological data. The next step is to determine the file pattern for each acquisition type in the study. The example shown on this slide is for a task-based multi-echo fMRI scan and is captured by a specific file pattern for each of the file names. After we determine the file pattern for each acquisition type in the study, we can then create the subject level support files and the project level files. Lastly, once we've determined the file pattern and all required files have been identified, then we apply the transformation across all files in the project. Oftentimes, this transformation, taking a data set to the BIDS standard, is a very iterative process, and implementing these 5 stages requires meticulous attention and a lot of time. This is further confounded by the scale of the transformation that's required to convert the DICOMs to the BIDS standard. This can be up to hundreds of files for any given study, with a very specific file pattern expected in each name of the file, along with certain expectations on the file contents. In addition, BIDS is an evolving standard, with the most recent version released just 2 weeks ago. Altogether, achieving the BIDS standard is non-trivial, but at Flywheel, we do have the functionality to mitigate some of this problematic process and infrastructure that empowers our users to automate the BIDS standard alongside their standard neuroimaging workflows. That being said, I will now talk about the available tools for getting to a BIDS curated data set in Flywheel. And then I will explain each component of import, curate, and view tools that we have available in Flywheel for BIDS. As we just learned, converting data to BIDS is quite difficult. In Flywheel, we have tools that empower you to achieve this important standard. One of these tools is the BIDS curation gear. This is built on a JSON schema and uses a JSON template that dictates a metadata mapping. In other words, the transformation from DICOMs to a BIDS compliant dataset is achieved in Flywheel using this JSON template and then storing the result of this transformation as BIDS metadata. It is worth considering that there is a setup cost before BIDS can be automated in Flywheel. And what this means is to create a JSON template for the project. However, this approach to curating a data set to the BIDS standard, namely using a JSON template, provides flexibility for adapting to the continuously evolving standards of BIDS. It makes it simple to edit and iterate through your data set during the curation process. Of similar importance is the BIDS curation gear, which uses this JSON template, and it is both flexible and fast. This also lends quite well to quick iterations during the curation process. There are 3 pathways to get a BIDS curated data set in Flywheel. The first method, and the fastest pathway to the BIDS standard, is via repro-in. Repro-in is part of the repro-nim center suite of tools and frameworks. This method sets the necessary information at the scanner to automate BIDS. In Flywheel, what this means is that your DICOMs are converted to NIFTs using the DCM to NIX Flywheel gear. Then you would use the repro-in template provided by Flywheel as input to the curation gear. Alternatively, another pathway, say if you have a legacy data set, or if you're collecting data in a clinical setting and don't have control over the console, you would still convert your DICOMs to NIFTs using the DCM to NIX gear, and then you would use a custom template as input to the curation gear. So to recap, you would convert your DICOMs to NIFTs, and then you're going to use a JSON template, either repro-in or a custom version, as input to the curation gear. Now we have several available custom templates that are stored in an open repository that can be used. Custom templates can be reformatted in their entirety, or more commonly and easier to implement is a simple extension of one of the Flywheel provided templates that are incorporated into the curate gear. Now, after you run your BIDS curation gear, either using the repro-in template or a custom template, the output is a metadata mapping that is stored in Flywheel as BIDS metadata. The third pathway is helpful if you have a data set that is already BIDS curated. For example, a data set from OpenNeuro. You can use our import tool to import the data set into Flywheel, again resulting in this BIDS metadata. Once you have the BIDS metadata, then the data set may be viewed in Flywheel to visualize the BIDS curated data set in its BIDS format. To understand a bit more about this BIDS metadata, it can be helpful to visualize the hierarchy comparison between Flywheel and BIDS. As shown here, our data model is very similar to BIDS, where we use the project, subject, and sessions hierarchy. The difference comes in into how the acquisitions are grouped and how the files are named. Both of these are stored in Flywheel as BIDS metadata, making it flexible to update and edit. And by storing the BIDS standard as metadata in Flywheel, your existing workflows can be seamlessly integrated. So let's take a closer look at this BIDS metadata in Flywheel. There are two places where the BIDS metadata is stored in Flywheel. Shown here is the BIDS metadata example at the project level. This information is equivalent to what is in the dataset description JSON file that's part of the BIDS standard. It contains information like funding, which BIDS version was used to curate the dataset, and the authors of the study. There are also files that are stored at the project level for the BIDS standard. These are things like the participants TSV file, changes, README, those kinds of files that the BIDS standard expects or suggests to be at the project level are also stored at the project level in Flywheel. The other place where BIDS metadata is stored is at the file level. This information dictates the BIDS standard for that file. Now, each aspect of the BIDS file name structure is stored in this metadata. In the example shown, the data type is an anatomy file, and so the BIDS standard states which fields are allowed. Only the fields that are allowed for a given BIDS standard are available as BIDS metadata on a file that's classified in that data type category. These fields are actually determined in the JSON template. For example, an ANAT file name can have a section for acquisition or contrast enhancement, and it's required to have the modality. In this case, in the example, is a T1 weighted image indicated by T1W. We can dictate whether or not a field is required or optional in the JSON template as well. These fields are then combined to create a BIDS file name, which is also stored as BIDS metadata in Flywheel. The folder and the path sections of the BIDS metadata are used for our view and export tools respectively. In addition, we also provide a valid indicator that you can see as a checkbox at the bottom of the screen. And this will indicate whether or not the file is up to the BIDS standard. Now let's talk through an example of how to get to the BIDS metadata for a file. Shown in this slide is a portion of the repro.in template, where the information to place into the BIDS metadata is determined. Given a series description, we can parse this using a regular expression. For example, the first series description is parsed, indicated by the coloring scheme, and we determine that the acquisition label for the BIDS standard should be MP-Reg. We then place this acquisition label into the BIDS metadata, indicated by the red color. A subsequent regular expression that would be in this JSON template and not shown here on the slide would parse this same series description for the run indicator shown in purple. Now you'll notice that the last series description has a different acquisition, in this case space. The same regular expression would parse this series description and place space into the acquisition field of the BIDS metadata on that file. So to summarize, we have a JSON template that maps metadata on the file, often coming from the series description and file classification, although any metadata can be used in the JSON template to dictate this mapping. And we map it into the BIDS metadata. Once we have this provides us with our BIDS curated dataset. To reiterate what I stated before, we have several JSON templates available in addition to the repro.in template that can be modified or extended for custom use on our platform. Now, if you have a BIDS curated dataset and you want to import into Flywheel, you can use our BIDS import tool via one of our other open source tools, the Flywheel CLI. This tool is simple to use, and you can import an entire dataset or portions of it using different command options. For example, you can use a subject option to only import a specific subject. Once you have a BIDS curated dataset in Flywheel, you can easily visualize this with our BIDS view tool in the UI. This is useful for visualizing your dataset in the BIDS format during the curation process. You will notice that there's a separation of the data types, as is the BIDS standard. In this case, both anatomy and functional are separate. And you may also notice the red flag that is on the last file. This indicates that the file is not BIDS compliant because I deleted the task information from the BIDS metadata. The BIDS metadata on that file would also not have the valid field indicated. An error message will appear if you hover over the red flag. That will inform you what the error is, although it's typically easy to see in BIDS view if you are familiar with the BIDS standard. In addition, the BIDS view tool will also show files that were not converted to BIDS. This can be a useful feature for debugging that will indicate if a file is not BIDS compliant or if it's not considered part of the BIDS dataset. Now that you have a BIDS curated dataset in Flywheel, we will talk about what you can do with it. I will now cover the export and analyze tools in Flywheel for BIDS. There are several BIDS apps, which are portable neuroimaging pipelines that understand BIDS datasets in the BIDS standard format. We have converted some of the most commonly used BIDS apps into Flywheel Gears, including those that you might be most familiar with, fMRI Prep and FreeSurfer. And these are available to use out of the box with your BIDS curated dataset in Flywheel. We also have tooling available for you to write your own gear that uses a BIDS dataset as input. The BIDS app template is an open source repository that you can clone and get started on. It comes with many of the building blocks that are needed to jumpstart the gear building process on a BIDS curated dataset. You can also export your BIDS curated dataset using, again, the Flywheel CLI. There are several options for you that allow you to export subsets of your data. For example, if you only wanted to export the anatomy files, you could use the data type flag and only export those files from your project. The output of BIDS export will always be a BIDS standard hierarchy and written out in that format. This can be quite useful for sharing your BIDS dataset, for example, on OpenNeuro or with other funding agencies. Lastly, I will discuss some upcoming features that we are working on to improve the BIDS workflow. First up, we are focused on improving the BIDS curation process by reducing the setup costs by providing a more user-friendly approach. We're also continuing to support and add to our collection of BIDS app gears. And importantly, we're going to continue to maintain the support with the ever-evolving specifications of BIDS, including updating our templates to the most recent version that was released a couple of weeks ago. That it also incorporates new standards for things like derivatives that will be wrapped up into those BIDS app gears as well. Lastly, we're improving our export functionality to streamline this export process to things like NDA databases. We are committed to the open science and supporting this BIDS standard and have many tools available for custom support. We are committed to BIDS and adapting our functionality around this, and we look forward to presenting several upcoming features to our users in the near future.
Okay, so Frank has a question, Maggie. Frank is saying, I know about the regular expressions. Hope more talks on different specifications such as files such as the TSV and field map and such.
Yeah, let me jump back to the slide with this here. To give you a slight understanding of how that works is there's different sections of the templates that will then dictate which file will have a particular mapping. So within the entire JSON template, you will have a section that's like you have a repro in a nat file. That's the ID of this rule that's going to be implemented on your file. And so you'll see that the template that's being used says a nat file. And if you look on the bottom right-hand corner of the slide, you will see that the template shown as a NAT file. So that's indicating that that section of the JSON template is being applied to this particular file. So in this case, we know that we're looking at series descriptions that are anatomy files. So I want to apply the BIDS specification for anatomy files, and that is indicated in this rules section of the template. So the rules section comes with a couple options. We've got this where clause that's in there, and that where clause tries to look at the different files that you have in your project and determine that it should be considered in a NAT file. And then the initialize section is where you can write those regular expressions to then partition pieces of metadata out of the series description or any other metadata that's available in Flywheel. You can use that to partition the information and dictate which fields need to be filled in for that process. So if you look, Frank, to kind of get a little bit more on that question, if you look at the full repro in template, each of the rules, there's a rule for field maps, there's a rule for functionals, there's a rule for a NAT. So there's a rule for each of these different types of files that are expected within the BIDS structure. Does that kind of help a little bit with your question? Or if you have another specific example, I could try to go through that.
Yeah. I think the other thing that's important, Frank, is being in touch with the person the PI or whoever basically set up the MR protocol for that particular scan to kind of understand what field maps go with what other fMRI acquisitions. So that, because sometimes, one field map is acquired for everything. Sometimes they alternate. So going back and speaking to whoever set that up is also important. So you are basically mapping those correctly.
Yeah, that's a very good point, Sina. Sometimes, the BIDS specification does require some information about how the data was collected. And so that information can be quite helpful when you're trying to figure out which portions of this template that need to be modified to capture that information from the data set that you have at hand.
And Maggie, can you also cover, if you know about this physiological recordings, if you have any experience with that?
Yeah, we have another gear in Flywheel that extracts physiological recordings from that data and places them into a BIDS structure so that they can be used for the BIDS curated data set. So that's a step that would be before applying the BIDS curation. After you've converted your DICOMs to NIFTYs, any other associated files like events files, physiological files would also need to be converted over. So the one gear that kind of handles that physiological data is available in Flywheel. It's called Extract CMRR Physio. We'd be happy to make sure that that gear is available for use as well for you, Frank.
Yes, it is on the exchange, Frank. So if you go to our exchange, Flywheel.io /gear-exchange, you just type CMRR, and I can drop this in the chat as well. But if you go ahead and do that, you would know what we're talking about. I'll send you a link to the GitHub repo here as well.
If you would like to learn more, please visit our website at Flywheel.io for webinars and documentation, or you can also send us an email at info@flywheel.io. And I thank you for your time.